Today we're going to take a look at how we can solve a systems of equations by graphing the lines. First, we need to know, though, what is a system of equations? Well, a system of equations is simply more than one equations that all work together, and there's only one solution that satisfies all of the equations. So for example, I've got the equation x plus y equals 1, and the other equation x minus y equals 3. There is one point, 2, 1, for an x and a y that is actually the solution to both of those. Notice if we add them together, 2 plus a negative 1, we get 1. And if we subtract them, 2 minus a negative 1, we get 3. The 2, negative 1 is the unique solution to both of these equations at the same time. While one equation has several solutions, an infinite number of solutions, the two together only have one. And that's what we're going to try and find. However, one does not simply solve a system of linear equations. We need a system, a plan to get there. Here's what we're going to do today. If a graph is a picture of all the solutions to one equation, then we take the picture of solutions to both equations and see where the graphs cross. That point where they cross is a picture of the solution to both. So visually what this means, if I have a blue line that goes like this and a red line that goes like that, you notice both lines cross at the point -1, 2. That point -1, 2 is on both graphs, on both solutions, which means it's a solution to both equations. That's what we're going to attempt to find today, is where do the lines cross? What is the solution to both equations? So here we have two equations, y equals 2/3 x minus 1, and y equals 2x plus 3. There is one solution to both of these, and we're going to find it on this graph. Now what's nice is we know that y equals mx plus b is kind of the way we graph all lines. Y equals mx plus b. So let's take a look at this first line. I'm going to graph this first line in blue. B, the y-intercept, we're starting at -1. So we'll start at -1 there. And the slope says we need to rise 2 and run 3. So rise 2, run 3. There's another point. And so we're going to get this graph of this line. There's the first line. The second one I'm going to graph in green. The second line has a y-intercept or starting point up here at 3. And its slope is 2. Well, if I make that into a fraction, 2 over 1, we're going to rise 2 and we're going to run 3. I'm sorry, run 1. 2 over 1. So rise 2, run 1. And so if I keep doing that, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, the graph kind of looks like this. But what we're most interested in is where do these two graphs cross? And they do have an intersection point right there. That is the solution to both equations. That's the backwards 3, down 3. So that is at the point -3, 3. -3. It's down 3 on both. -3, -3 is going to be a solution to both equations at the same time. Any other value won't work for both equations, but -3, -3 does work on both equations. Now this one was nice because they were both in y-intercept form. But our equations don't always come to us in y-intercept form. Sometimes we're going to have to do a little bit of work to get them there. So let's see. I'm going to move this first equation over. 3x plus 4y equals 4. Now when we're in slope-intercept form, what that really means is we have y equals the stuff. So we need to get the y alone. So I'll subtract the 3x off from both sides. And that gives us 4y equals, we like the x to come first, so negative 3x plus 4. And then to get the y alone, we'll divide by 4. And we can divide the whole thing by 4, but I'm going to show that in pieces, dividing each piece by 4. That way I can clearly see the slope is negative 3/4 x plus 1, my y-intercept. So we'll start at 1, my y-intercept. And the slope is down 3 over 4. We can also go backwards, up 3, backwards 4. And we end up with this nice little line here showing all the solutions to the first equation on the blue line. The second equation, we also have to get in a slope-intercept form. So I'll balance that second equation, first getting the x out of the way by adding x to both sides. And we get 2y is equal to x minus 8. Get the y alone by dividing by 2. And while we could divide the whole thing by 2, I want to show that each part gets divided by 2 so I can clearly see that that's 1x over 2, or 1/2 x minus 8 divided by 2 is 4. So we have a y-intercept of negative 4. And we're going to rise 1, run 2. And we end up with this graph down here in green. And again, we're overjoyed when we see the two graphs cross. They have one point in common. That point is to the right 4 and down 2. So when x is 4, y is 2, that solution will work in both equations simultaneously. So how do we solve a system of equations? We can graph both lines, and where both lines cross, that is our solution. Now you know how to solve systems, so give it a go on the homework. Hope you found this video helpful, but let your instructor know if you still have any questions.